Alright, atomic structure by Jacob, Broderick, and Blaine. Alright. Atoms and ions. An atom is the basic unit of a chemical and has the same number of protons, neutrons, and electrons. Right here, as you can see, we have a nitrogen atom. As you can see the nucleus with the protons and neutrons and electrons orbiting it. For an ion is an atom/molecule with a net charge due to a loss or gain of electrons. Right here we have a nitrogen ion with a -1 charge. You can see it's exactly the same, just has one more electron. Nitrogen atom. Here you can see how to find where the protons, neutrons, and electrons are located. In here, as in the middle of the nucleus, is the protons and neutrons. It's where they are located. To find electrons, you find electrons as they circle the nucleus around it. For this nitrogen atom, it has 7 protons, 7 electrons, and 7 neutrons. For a nitrogen ion with a -1 charge, everything's the same. Protons and neutrons are located in the nucleus, and the electrons still orbit it, but with a -1 charge, the nitrogen ion has one more electron. So in this it has 7 protons, 7 neutrons, and 8 electrons. Alright, for an oxygen atom, you can see it has the 8 as its atomic number, its symbol, the name oxygen, and its atomic mass. To find it from right here on its own element table, to find protons equal the same amount as the atomic number. So oxygen atom has 8 protons. To find neutrons, you subtract the atomic number from the atomic mass. The atomic mass is 16, so subtract 8 from 16 equals 8 neutrons. To find the electrons equal the same as the atomic number and the protons. So this oxygen atom has 8 electrons. Right. For an oxygen atom an oxygen ion that has a -2 charge, everything's the same, it's just up here it has a -2 charge. So to find the protons is just the same. It equals the same as the atomic number, so it has 8 protons. For the neutrons, the exact same way, you subtract the atomic number from the atomic mass, which gives you 8 neutrons. The only difference is for electrons. Electrons equal the same as the protons and the atomic number, but an ion with a negative charge, you add 2. So since the ion has a -2 charge, the negatives add more to it. So you'd add 2 to it, so 8 plus 2, you get 10 electrons. Alright. Here's another example of a carbon atom. It's the exact same way. You find everything the same. The protons equal the same as the atomic number. For neutrons, you subtract the atomic mass from, you subtract the atomic number from the atomic mass, and you get the same number of neutrons. And for electrons, exactly the same. It means the same as the atomic number or protons. Now for a carbon ion that has a +1 charge, you can find everything the same on the table. It just has a +1 charge. So in this, your steps will be normal. You find number of protons from the atomic number. To find the neutrons, you subtract the atomic number from the atomic mass. But the only difference is finding the electrons. The electrons equals the same as the protons and the neutrons, but with an ion with a positive charge, you subtract. So with the positive charge, it cancels out and you lose an electron. So you subtract that 1 from the amount of uh, electrons there was before. So 6 minus 1, you get 5 electrons for a carbon atom with a +1 charge.
An isotope, there's only a few differences between an isotope and an ion and an atom. An isotope has the same number of protons but a different number of neutrons within the nucleus. An atom contains the same amount of protons, neutrons, and electrons, and an ion contains the same number of protons and neutrons but a different number of electrons. Some of the similarities are that the ion, isotope, and the atom, they all still have the same number of protons. A lithium isotope. Lithium has a atomic number of 3 and a mass number of 6.9, but you round when it comes to subtracting. To find the number of protons, you use the atomic number, and the atomic number of protons is 3. To find the number of neutrons, you subtract the atomic mass from the atomic number. So if you subtract the atomic number, which is 3, and you subtract that from the 7, you get 4. So there are 4 neutrons in a lithium isotope. In a tin isotope, there's an atomic number of 50 and a mass number of 118. To find the number of protons, you still look at the atomic number. So the atomic number is 50, which means that there are 50 protons. To find the number of electrons in an isotope, it's still the same number as the number of protons. So the number of electrons is 50. You subtract the atomic mass from the atomic number. So you're going to subtract the atomic mass, which is 118, and you're going to subtract 50 from that, which is the atomic number, and you should get 68. So there are 68 neutrons in a tin isotope.
For the average atomic mass is the average mass of atoms of an element, calculated is using the relative abundance of an isotope in a naturally occurring element. So take carbon. Carbon that has a mass number of 12 has the exact weight of 12. For a mass number of 13, it has 13.003355. And the percent abundance for them is 98.9 for a mass of 12 and 1.110 for a mass of 13. How to find this? You take the exact weight times its abundance. So 12 times 0.989. Then you do the same for the other one. You take the mass, which is 13.003355, times its percent abundance, and then you take those two totals and you add them together, which gives you a 12.011 AMU. Now it's your turn. Take a shot at it. Now for ion problems. Now take a shot at isotope problems. And now for average atomic mass problems. And now
The end.